Welcome everyone to the very first of our Viper Chats. And a Viper Chat is an opportunity for us to participate in critically reflective teaching practices, one of which is to share stories with our peers. And so I'll go ahead and introduce myself. I'm Shirley Lynn from the U.S. Naval Academy, and I will let the other members of the group introduce themselves now.
And I'm Justin Pratt. I'm at the Maine Maritime Academy.
I'm Anne Bentley. I'm at Lewis and Clark College.
I'm Joanne Stewart, and I'm at Hope College.
I'm Jeff Raker. I'm at the University of South Florida.
And I'm Barb Reisner. I'm at James Madison University.
So today we're going to be having a conversation around this question of what can we do as instructors to help our students feel a sense of belonging in our classrooms and as chemists.
So I get to go first. And one of the things I do in my introductory classes is on the very first day of class, I have the students in small groups talk to one another, and I pose the question of, how do you know if a chemical reaction has occurred or not? And what would be evidence of a chemical reaction? And so they come up with a list of ideas, and I have the groups report out. It's also a chance to start training good group skills as well. And so they say, oh, if something changes color, or if something explodes or whatever. And so I make a big list of those, and of course congratulate them for all their great ideas. And then I often have a series of demos. So then I do have hydrogen balloons that I can blow up, and I'll do something with universal indicator and dry ice and whatever I can to make it look like what might stereotypically be chemistry. And so my point is that I want them to know that when they walk in the classroom, they already know some chemistry. They're not coming in, without that experience that they've had. So they're already thinking like chemists.
I have a question, Joanne. Do you think that this technique would be similar, different if you used it in an upper level class?
Well, that's a good question. I have an inorganic activity that I do later, that one of those sort of what do you know about kind of activities. So I do one where I think it's on Viper. It's one where they just list everything they know about orbitals, because orbitals are so abstract kind of thing. And they just make a long list of that. And so that kind of helps, again, recognizing that they're coming into the classroom and they belong in the classroom. They bring in some knowledge with them.
Joanne, I like that idea has both acknowledging them as a person and what they bring, but also then situating them in the classroom. And you had mentioned kind of in passing it sets kind of the standard for how things are. And so, it is one of those where that double kind of thing, like it almost doesn't matter what the question is, but it's getting them kind of in that perspective of talking.
Thanks.
Cool. I'll share my little story next. It's very small. It's things I do in all my classes as I'm going along to kind of normalize the learning process and show that learning is an ongoing process, and that nobody is inherently more knowledgeable by birth than someone else. So I talk about, just as I go, I think of things that confused me when I was learning chemistry. And I do not know when I learned that chloride was Cl- and chlorine was Cl or Cl2. Somewhere I learned that, but I know there was a point early in my chemistry knowledge where those kinds of terms were very confusing to me. So I just try to point out to the students that I also had to learn all of this at some point in the past, and kind of normalize where they are in their learning and make that totally acceptable.
I really like that idea. I do it without knowing that I do it. And so like, I'll be like, oh yeah, I struggled when I learned this, and it's going to take practice and extra, problems for you to make sense of it. And so I really like now, like purposefully doing that. And so maybe thinking about how I can do that for all the topics we cover, and have some sort of kind of peel back the curtain on us as a professor, me as a person, kind of a little bit.
Well, and you run the risk, you don't want to make yourself look like a complete bumbling idiot, I think you have to be sensitive. You have to be at a certain point of confidence, or not confidence, but achievement to so that they'll trust you on it, or, you don't want to make it look like, I don't know. Yeah, you want to be careful about it, but yeah, not overdo it.
Yeah. One of the things I do in that vein is just remind them that a lot of the learning that
goes on outside of the classroom. So like I did my learning way back in the dark ages, and that person that they're working with who really seems to understand it, you just haven't seen the time that they put into learning. So I try and normalize that a lot of this learning is invisible and there's time that comes outside of the classroom.
And yet in that moment, then I have the humanistic aspect of realizing just how long ago it was that I wrestled with learning some of the things. So it helps to situate me in the classroom in terms of might look young, but it's been a while.
I guess I can go next. One thing that I like to do with this idea of belonging and feeling like a chemist is, particularly in lab, trying to give basically every week some component that they get to design or think about. So if it's like the lab we're doing this week, we're going to do relative solubility. So does it dissolve in different substances? And then once they know which one it does dissolve in, then they get to come up with their procedure to figure out what's the actual solubility. So however much in a certain volume. And so there's this chance for them to build off of something I've told them how to do, but actually design it themselves. And so these experimenting skills, giving them a chance to see that, well, you've learned stuff and now let's try it and actually be a chemist in the classroom.
Yeah, I love
lab.
that sort of demonstrating expertise. I love that. And also because that sense of ownership as well. It's like, well, this is my solvent, you know.
Mhm.
And that really, you know, students, I think they really like to have that sort of that feeling of expertise.
And it's harder as you, the instructor, because now you have to think, well, what tools might they want? What do I need to have prepared just in case they want to try it? So there's a little more prep work on your end as the instructor, but I think it's definitely worthwhile for the students.
It's really cool how you have designed that around an experiment that it's safe to do a lot of different designs of, you know, whereas one could imagine that if you were just saying to students, well, you could just mix these chemicals together to see what happened. I mean, that's not usually going to have a happy ending, right? So that's solubility is an excellent example of.
Isn't that what Joanne does on her first day though? Mix them together, big kaboom.
See what happens.
I guess I can go next. So when I think about belonging, one of the things that pops into my head is trying to get them to feel like they're part of the broader scientific community. And I start my Gen Chem and even my majors classes with what is chemistry? What do chemists do? And I ask them, what problem is it that they want to solve? And what really gets them passionate? And of course you get answers all over the world. But then I go through some examples and I see a lot of pre-meds. So I will talk about things, well, chemists, they develop methods of detecting diseases. And my favorite slide to put up is a colorimetric Zika test that you can do in the field and just show them like there are all these problems and you're learning the tools to put this together and you are going to be the people doing this at some point in saving the world.
That's awesome.
Barb, I'm so glad that you shared that because it really links to my piece, which is bringing the person into the classroom. And I do it in a big way in the sense that I really like teaching in the fall. So I get to do Nobel Prize Day and I will wake up early and listen to the call. And what has been fun is that you get all those materials from Nobel Prize Committee, but it really boils down to very simple kinds of things. And I like to share that to my students and go, you know, yeah, you got to learn a lot of chemistry to be Frances Arnold and do all the crazy stuff that she does. But when you start looking at what was the little idea, like I teach organic predominantly and retrosynthetic analysis, starting with the end in mind. That was the prize. There wasn't really, and so it's these little kinds of things that like, yeah, you got to know some chemistry, but it really situates it with the person. And so I like to point out the chemistry that we're learning in the course, how it connects to it. I also personally have been at 2 institutions where Nobel Prize has been awarded. So I like to play the, like, you're not that far away. Like through me, you're connected to a Nobel Prize winner. And, you know, it's a big aspiration thing. I have a lot of students who are very motivated. Like they want to change the world. And I want to embrace that and go, yes, learning symmetry elements. It may be a mundane thing, but it really like, that could be the piece that unleashes and I think that's kind of the inspiration side too of situating a student in a classroom and going, you belong here and your ideas belong here, and it doesn't take some dramatic thing. It
Well,
could just
two
be
things real
going,
quick off of that. Yeah, I love that. So with Barb, it's sort of like acknowledges the things they value. And I really like, you know, they get to kind of, these are things I value and I get to talk about them in my chemistry class. And that's really cool. And then what Jeff said, it's this sort of like, it's not that far away. Yeah, if I ever get a chance, I try to say like, oh, and this person, I try to do with alumni, right? This person graduated from Hope College. They were sitting in your seat not long ago, you know? And so, yeah.
Well,
We
I
have
just
that fun. Yeah, we do that too. This Nobel Prize winner used to be a dishwasher in college for this person who's now a professor at our school, you know, like little connections like that. Like you got to start somewhere.
You got to start somewhere.
they're people. Chemists are people, I think. Yeah.
So I just want to thank everyone for participating in today's Viper chat. And I want to encourage those of you who saw this video and would like to just share the conversation to go ahead and post something to the nanoCHAT channel in the Viper Pit, our Discord. So thanks everyone again, and signing off.
Thank you.